Hey everyone, this is Senior Design 2 in fall of 2023. We are Group 4 and we are demonstrating a 18650 battery tester for ASU's Interplanetary Initiative Labs. To start, we have a 12-volt DC power supply that feeds DC power into the 4-quadrant synchronous power supply.
Our 4-quadrant power supply feeds into our load with voltages ranging from 5 to -5 volts with 5 amps out. It is controlled via a 16-bit DAC that receives information from an Arduino Nano via I2C. The Arduino takes current measurements from the current sensor board and calculates the appropriate voltages in order to maintain a voltage across the load.
In addition, we also have an analog thermistor that is used to monitor the temperature of the battery to shut down if the temperature gets too hot. On this screen, you can see our dashboard. We have the load voltage, the current through the load, our DAC control voltage, the temperature from the thermistor. We can also get a graph output of this, which we can download the historic data for. Below, you can see cells 1 through 4. We currently only have the code running on cell 1, but because this was designed to be expandable, we do have room for 4, and with a simple kill command, we can turn each cell off if we want to. Additionally, on the right-hand side of the screen, we can see the output from my analog Discovery 2. So we can see a wired reading in real time as opposed to the IoT remote reading.
Starting our demonstration test, we will test some of the 4 quadrants ability. So we are now simulating a sawtooth signal, which is generating a load voltage 0 to 5 volts, which is controlled from the DAC voltage. As you can see, it's jumping from 0.55 up to about 1 volt, and our load voltage is rising accordingly. We can exit and go on to a next waveform, which will act like a capacitor, slowly charging and then slowly discharging. Again, we can see the DAC control voltage is slowly rising. And once we get to about 4.8 volts, 5, it'll reduce back down. Moving on to our next test. We will set a constant current of 40 milliamps roundabout, and our Arduino will take current measurements and calculate the correct load voltage to apply in order to maintain this current.
Additionally, you can see our simulated load of 100 ohms, and I have a second 100 ohm resistor wired in parallel with this button. When I press this button, they will connect, which will change the resistance. The controller will recognize this and drop the load voltage in order to get us back to 40 milliamps. You see that worked perfectly. And when I release the button, we'll be back to a single resistor and the voltage will jump back up. You can see right now we're just under 2 volts. When I let go, it jumps up to 3.8 to get us right back to the 4.2 milliamps. With an actual battery, our currents will be significantly higher than this, but for demonstration purposes, we wanted to keep it simple. And to wrap this up, we could run an exit command but we wanted to demonstrate the thermistor capabilities. If at any point during this test, this thermistor gets above 90 degrees, the entire test will shut off. I'm just rubbing it to heat it up. And it's killed. In reality, with the battery, that would be closer to 140 degrees. However, again, for demonstration purposes, we wanted to keep it simple. And with that, that concludes our live demonstration. Thank you for watching.